Hello guys, welcome back to my channel, The Boy. So in this Seimolkoi special videos, I will be talking about software that helps chemical engineer to do their job beside the regular process simulation software. And today I will be talking about Unisim Flare. So what is Unisim Flare? Unisim Flare is a steady state simulator. It is a standalone software to evaluate and to calculate van or flare systems. So this is basically a back pressure calculator that will calculate the pressure flow network from the flare tip to the flare source. So it's basically similar to a hydraulic software. Okay, so before I go to the software demonstration, make sure you have subscribed to the channel, like these videos, and share if you think that this video will be useful for the others. Okay, let's go. Okay guys, so this is the first interface when we open Unisim Flare. We can just click this to create a new model. Example. Okay. Now, similar to the process simulation software, we need to input the components. Yeah. So this is just an example, so I will put anything there. We'll click that here. Okay. Now we have the PFD and we have the model palette. So basically, this is quite similar with how we do the process simulation software. So we have the pipe here, and then the flare tip, the relief valve, uh, and then connector, control valve, T, separator, orifice, flow bleed, and also horizontal separator. In this simulator, we have two sources of it. Okay, the first one is relief valve. Yeah, this is the first source. Okay. And the second one is control valve. This is the second source. Yeah. Okay, I will put it in the flow sheet. So basically, we need to connect this source to the flare tip. And to connect this source to the flare tip, we will have some pipelines. So here, for example, I will create a pipeline. And pipeline, sorry. Yeah, and we will connect the source to the pipe. Yeah, something like that. And then if we want to mix these two source, we will need this T. Yeah, we'll connect to both of the source here and another pipeline. Okay, that pipeline. Then if we want to connect pipe with another pipe, we will have an automatic connector. Okay, something like this. Because this one is actually similar with the hydraulic simulation. If we want to have a resistance node, we need a connector in between. Yeah, for example, this connector or maybe a T. Yeah, so we cannot connect two pipes together directly. The same as we cannot connect connector and T and also separator directly. Okay, so for example, I'm going to have a separator here. Okay, to another pipe. And finally to the flare tip. Okay, so this is an example, yeah, a very simple example of flare network, yeah, where we have two sources connected to one source and go to the flash drum. We going to the flare chip. So the next stuff is we need to specify the inlet pressure, the lower back pressure, and also the mass flow. So the mass flow is more the most important one actually, because this mass flow will determine the pressure flow network. The same as well for the daily valve, we will need to have the mass flow, the rated flow. So how this simulation work is by having a flow specification at the upstream and pressure specification at the downstream. Flow specification at the upstream is the flow that we specify in the sources, while the pressure specification in the downstream is 1 atmosphere, where the flare tip, yeah, will be fan or will be flared to the atmosphere, right? So by having the flow specification at the upstream and pressure specification at the downstream, so the software will calculate what is the pressure at the upstream, and later we will evaluate, or we will evaluate the comparison between the calculated pressure at the upstream with the allowable back pressure. So it is one of the use of this software. Another thing is, because we have a pipe model here, we also could evaluate what is the velocity of the fluid inside the pipe. Because for a flare system, based on the standards, we have the max Mach number, also rho v square, and also the max noise, or dB. So it is also required to evaluate these parameters. So in this pipe, we have a page to specify the length, the elevation change, the material, and also if we have any fittings here. Okay, so I will show you an example, yeah, where we have the simulation result. So if you see here, the software calculates the pressure at the upstream, yeah, 30 bar at PSP1, 109 bar at PSP2, 10 bar at FCV1s, and so on and so on. And we could see that at this PSP point, we get some warnings. Okay, to view the results, we will see here, view results and pressure flow summary. Okay, so this simulator will give you warning on the parameter that is not good. So for example, here is the upstream Mach number. Actually, this is not too high. 0.3 is still okay. We could we could give a settings to this threshold, yeah. So don't worry. Okay. And another thing, we also could show the sources also. Yeah, PSP2, PSP1, and other things. And then we also could see the profile, yeah, the profile of pressure from PSP1. So we could see here the pressure of the source pressure calculated is about 4 bar G. At the tip, it will be 0 bar G, or 1 bar absolute. Yeah, and this is the allowable back pressure. So since the node pressure is lower than the allowable back pressure, so for PSV1, this PSV is still okay. It will perform good, well, yeah, it will perform well. Okay, so we could also evaluate the Mach number. Yeah, so this is the profile. You could see that it will increase significantly at the flare tip. Okay, so this kind of evaluation we could make in our simulation. And last thing I will want to show to you is about whether the software is capable to do a plant-wide flare system network. The answer is yes, it is possible. So this is an example of the plant-wide flare system. We could see the source here. We have like, yeah, around 20 source of flare. So yeah, it is possible to do this kind of stuff. Okay, and we could also see results. Yeah. Okay, run. Okay, so this is the result. And here we could also specify the scenarios. Yeah, for example, in this large lucid, which source will be active in our scenario? Is it all of the sources, or we want to evaluate a single source? So it is also possible. So that's it for the introduction. I hope this video will help you to know a little bit about the software, and you could learn it from other source, or you can learn it yourself from the user guide manual. Thank you for watching this video, and see you at the next episode. Bye bye.